All right, finishing up our day one assignment. You should actually try this one on your own first. Go ahead and pause the video and then come back when you're done and see how you did. All right, so for our roots, we need to set our numerator equal to 0. So 2x minus 5 equals 0. So 2x is equal to 5, and x is equal to 5 halves. So we get 5 halves, comma 0. For our vertical asymptote, we need to set our denominator equal to 0. 5x equals negative 10. And so x equals negative 2. For togetherness, we need a perfect square somewhere. And we don't have a perfect square, so there is no togetherness on this one. End behavior is your top heavy, bottom heavy, or balanced. This one is balanced because we look at the exponents to determine that. One exponent up here and a one exponent down here. So that's balanced. And remember, when it's balanced, you have to divide the coefficients in front of those x's. So 2 divided by 5 is 2/5. So our horizontal asymptote is y equals 2/5. All right, and lastly, we have our y-intercept. We need to plug in 0 for x. So 0 minus 5 over 0 plus 10. Negative 5 divided by 10 reduces to negative 1/2. So 0, negative 1/2. All right, so if we plot our points here, 5 halves is 2.5. Negative 1/2 is right there. X equals negative 2. There, and then y equals 2/5, so that's 0.4. So a little bit above the x-axis on this one. All right, so one of our curves has to be in the bottom right because it's going to go through both our y-intercept and our root. Not going through the asymptote this time because the asymptote's above the x-axis. To go through the asymptote, your asymptote has to be on the x-axis itself. That's the only time that'll happen. And since we have no togetherness, our other curve will have to go on the top left. All right, we'll finish this up with number 6. So this one's going to be quite a bit different looking, and that has to do with our denominator. So we saw a quadratic on a previous problem, and when we factored it, we got a perfect square. So it was similar to another problem we'd already done. That's not going to happen this time. So this one's going to be quite a bit different looking. We are still going to start out by factoring that denominator. We need different signs because of the minus 3, so plus and minus. And the only thing that multiplies to 3 is 3 and 1, and those do add up to 2 if we put a positive 3 and a negative 1. All right, so remember for roots, you set your numerator equal to 0. However, if there's no x in the numerator, then you have no roots, so just none there. This is the different part, the asymptotes. We're actually going to have 2 different asymptotes on this one. We have to set both of these factors equal to 0. So one asymptote is at x equals negative 3. The other asymptote is at x equals positive 1. Togetherness, remember we do have an x squared, but it has to be a perfect square. And this is not a perfect square because we got 2 different factors. So we still have no togetherness on this one. End behavior, our exponent on the top is a 0. I know 2 has an exponent, but we're looking for an exponent of a variable. And since there is no variable there, it's a 0. Bottom's exponent is a 2. So definitely bottom heavy. And we have memorized that now. Automatically y equals 0. Lastly is our y-intercept. So y equals negative 2 over 0 plus 0 minus 3. So the negatives cancel, and we end up with 2/3. So 0, 2/3. All right, let's see what this graph's going to look like over here. So no roots. We'll start with our asymptotes. X equals negative 3. And x equals 1. Y equals 0, x-axis. And 0, 2/3. So right about there. All right, so drawing in this curve, we know like one curve has to be in the middle here because it has to go through our y-intercept. So I'm going to kind of start close to this asymptote over here. I'm going to go through my y-intercept, but the horizontal asymptote is going to push it back up as it gets close to this asymptote. So it's actually going to look a lot like a parabola in here. It's not exactly a parabola, but it has similar characteristics to a parabola. And then togetherness will tell us where our other two curves are. So this graph has 3 different curves, right? Quite a bit different than our other ones. So our other 2 curves are going to be, they can't be right next to the one in the middle. So one of them has to be down here in the bottom left, and the other one has to be over here in the bottom right. Okay, remember we can't have one in the bottom middle because then it would fail the vertical line test. All right, that is it. Hopefully you will give some of the practice problems a try and join our video chat to ask some questions or get some help, and I'll see you then.